Hey everyone, continuing in Module 3, Topic 2, Lesson 3, Activity 3. We are on page 429 and 430. Still keeping with the same habits of mind. Reasoning with fractional coefficients to solve equations. It says, consider the equation 4/5 x equals 1/10. How is this equation different from the equation you solved in the previous activity? So in the previous activity, we had just grab it one here. So in the previous activity, we had 4/5 x equals 12 or 3/4 x equals 8, but now we have 4/5 x equals 1/10. So in this one, the coefficient and constant, remember that's just the number without the variable, are both fractions. So how on earth are we going to make that work on a double number line? Okay, so let's check it out. It says compare the solution strategies proposed by Zoe and Landon, and it shows that they are both correct. So step what? So it goes from 4/5 x up to 4x. I don't know if you guys can see the flashing on the screen. I do here, and I don't know why. Okay. I don't know, I just adjusted the light. Okay. So how do you go from 4/5 x just to 4x? Well, the denominator 5 must go away. So how does that happen? She must have to, looks like, multiply by 5 there. And then goes back to just x, which is the same as 1x. So to go from 4x just to x, it looks like she divides by 4. Okay. So to go from 4/5 x, if she multiplied by 5 on the 1/10 side, multiplying by 5, she gets 5/10, which they're saying is then 1/2, which it is, equivalent. And then going from here back to here, dividing by 4, half of 4, so 1/2 divided by 4 is the same as 1/2 times 1/4, keep, change, flip, multiplied by the reciprocal, which would give us the 1/8. Okay, so I'm getting that. So number 3, it says, on the double number line of each student's work, show the operation performed in each step. So I wrote it there, but we're going to write it here too. So Zoe, step 1, multiplied by 5 to eliminate I was going to say the variable, I mean the fraction with the variable. And then step 2, oops, sorry. So from that, she went from 4/5 x, boy oh boy, 4/5 x times 5 took her to just 4x And on the other side, 1/10 times 5 gave her 5/10, which equals 1/5. Then step 2, she divided by 4. To go from 4x to 4. So 4x divided by 4 gives her just x, and then on the other side, oops, that's 1/2. How did I write a 5? 1/2 divided by 4, if I write it this way, it's then 1/2 times 1/4 gives 1/8. It's an equal sign. Okay, so there's Zoe. So what did Landon do? He went right from 4/5 x to x. Well, how do you accomplish that? This goes way back to the very first right back to the introduction. I wanted to call it an activity, but it's the introduction of this lesson when we multiplied by the reciprocal to get 1. So we had these questions. So remember when we did 4/5 times 5/4 and we got 1, which happens to be the one they're giving us right now. So 4/5 times 5/4 gives us 1, or 1x. So it looks like he just multiplied by the reciprocal, multiplied by 5/4. And if you multiply 1/10 by 5/4, you get 5/40. Well, you're going to say, well, that's not 1/8, but it does reduce. Divide them both by 5, and you get 1/8. Okay, so just to kind of restate here, Landon took the fraction and multiplied it by its reciprocal to eliminate the coefficient. Landon, he multiplied, I'm just going to keep it short because I'm running out of room, by 5/4. Really to go directly to the x value, to the x. So he multiplied by the reciprocal of the variable. Four fifths x times 5/4, or I'd rather put it like that, equals just x. And then 1/10 times 5/4 equals 5/40, which equals 1/8. Okay, pause if you need to copy that down. Okay, so in this one, they're giving us a double number line to solve it. Okay, so 3/4 x equals 2/5. So 3/4 x, I don't know, we'll put it about right here. It doesn't really matter where we put it. 3/4 x equals 2/5. Now, if we used Zoe's method, we would multiply by this denominator to get rid of the fraction. So we would do a times 4, and that would get us, so if we had 3/4 x times 4 over 1. We get 12 over 4, which is the same as 3 because these 4's cancel out. So we get 3x. So if we did 3/4 x times 4, it'd put us like maybe up in here somewhere with a 3x. And if we multiply this side by 4, so 2/5 times 4 over 1 is going to get us 8/5. And then we need to isolate the variable, so get rid of the 3, so divide by 3. Right, so 3 divided by 3 gives you just x. So when we're dividing, we're going to go back to just x. I'm going to erase this because I've run out of room here. And if we do 8/5 divide by 3, we will do multiply by the reciprocal instead. 8/5 times 1/3. We will get 8/15. Okay, so you might look at this and go, well, how do I go right from 2/15 to 8/15 on this number line and then up to 8/5? Like, it might not seem to make sense, but let's count this out. So if this is 1x, 2x would be here. So if we were just looking at 15ths, and we're going from 8/15 up to here, from 1x up to 3x, we're increasing by groups of 8/15. So this would be 16/15, and that add another 8, this would be 24/15. 24/15, if you divide them both by 3, we reduce this. 24 divided by 3 gives us 8. 15 divided by 3 gives us 5. So 24/15 and 8/5 are equivalent. So it does match, it does line up, it does make sense. Okay, so x is 8/15. Okay, let's look at Landon's. So we're going to use Landon's method here. We did Zoe's here, we're going to use Landon's here. So for Landon's, he did multiply by the reciprocal. So instead, because that's essentially what's happening here, right? We're multiplying by 4 and then dividing by 3. Notice, isn't that the same as the reciprocal of 3/4? It's 3/4 x. If we multiply by 4 and then divide by 3, we have the reciprocal right there. So let's do that here. So 2/7 x equals 4/9. So if we multiply 2/7 by the reciprocal, it's going to take us just to x. If we started here at 4/9 and then we multiply that by the reciprocal, which is 7/2, it's going to take us to 28/18, which we can reduce this. I can get one whole group of 18 out of 28. There would be 10 out of the 18 left. I can simplify this even further. These are both even. I could divide them by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. So 2/7 x equals 4/9. The x equals 1 5/9. If we kept this as improper, if I would have reduced it to here, it would have been 9 plus 5. It would have been 14/9. Let's put that back into our original and see if it's correct. So if 14/9 is our value for x, and we are multiplying it, it says we should get 4/9. If I did multiplying straight across, I would get 28 over 63. Well, how am I getting to 4/9 out of that? Well, I could divide them both by 7. 28 divided by 7 is 4. 63 divided by 7 is 9. You can do the cross canceling. 7 goes into 7 one time. 7 goes into 14 two times. Then when you multiply straight across, you get 2 times 2 is 4. 1 times 9 is 9. Okay, and it says you learned how to solve addition equations by first reasoning with double number lines and then with inverse operations. Now you solved multiplication equations by reasoning with double number lines. How do you think that you can solve these equations without using double number lines? Oh, kind of like what we did here. Like, we wouldn't need to draw this out here on the picture, right? We could just, I can use the inverse operations to isolate the variable, right? Because we need to get it down to just what the variable is. We need to just x equals, right? Because here, this is what equals x. Oops, not that one. Sorry, that was our solution. Right here, this is what x equals. X equals this. It's not a good place to write it either. X equals this. Up here, x equals 8/15. I can use the inverse operations to isolate the variable. To solve the equation. Okay, and we'll see you on the next video.